Welcome back, everyone. And today's going to be a fun one. Today's one of those kind of things I've been wanting to do for a past long time. That we're finally at a certain point in experience and fungi's development that we can start doing some really fun effects. One big effect I've always been wanting to do is force fields. I've been seeing it on Unity all the time. They're really cool effects, like this one. So it's like a really cool effect where you kind of create a sphere and it somehow intersects objects that go through it or objects that it touches. And it's kind of neat that there's some distortions depending on which implementation that you're dealing with. Trying to think. There's another good one. This one. This one is like kind of where I really want to go. I like the idea of having the textures that animate and distortion inside the field. I also would like to be able to kind of maybe shoot a laser beam, and there's kind of like maybe a reflective like ripple that happens. I would like to try to experiment and see if I can get something like that working. But now the thing is, this is kind of a segue from the previous video where we kind of built everything up with deferred rendering and setting up the ability to read from depth maps, depth textures, because this effect requires depth textures. Now, it's really easy to do this in Unity because you'll find tons of tutorials on how to do it in Unity. Problem is you can't really find any examples of how to do it in WebGL, and for obvious reasons, because you have to set up depth buffers and things like that. Everything we did in the previous video, it's what we need to actually get to this point. So we're going to really just work on building a shield wall like this. So we're going to just do a simple shield wall and kind of create that effect of things that intersect, like here. So you can see that thing. You have objects that intersect with the shield, with it. And like I said, this is all post effects. This is kind of like blurring the screen or anything. This is something, when all said and done, we're done rendering everything, we draw this on top of that one texture scene, that entire frame. So these are actually post effects that we're doing. So let's check out some things. So there's some quick changes to fungi. So I updated the deferred rendering style. Shader. I slimped it. We have a new shader called intersect highlight. I have a new file called underscore snippets. I'm going to put in a shader folder because I'm starting to find a lot of really cool, useful GLS code, and then I kind of just misplaced them in all the lessons, and so I'm just going to create a snippet file, and any cool code I find or we use, I'm just going to throw it in there. So there's always a quick reference to find stuff that is really cool to do inside our shaders. Or just useful functions like this function that I kind of, in the previous video, I said I managed to find one really good equation that actually allows us to take depth information and kind of convert it into a value that we can use very well. And I decided to give it a name because, like I said, there's just a bunch of code I found. So I'm calling it map depth to projection, because what we're doing is we're taking, because depth information is between 0 and 1. So we need to kind of take that 0 and 1 and kind of project it, or map it to a value between our near and far. So that's why I'm calling it the map depth to projection. So we're mapping our depth values. But that's going to be inside our intersect shader. You'll see that later. And did some changes to fungi. They're not that big a deal. You can ignore some of these just because lines got, white spaces got changed, I think. Just white spaces. The big change is really setup deferred. I decided to take a lot of that boilerplate code and try to make it abstracted away so we don't have too much code messing inside our HTML page. So those are that's really kind of the big changes. I had to put some imports in there just to act so we can do things. So with that out of the way, so there's just quick changes that we need for this lesson. If you're following along, or you can just get everything from GitHub. So like I said, here's snippets. I saved the pixelated post effects grid from the previous video because I took that out of our deferred rendering. Here's our deferred rendering. This is the one that takes the entire color texture and then just renders it on a quad for the entire screen. So I kind of took out all the garbage from the previous video and just made it simplified. It's very simple. That's all it does. So that post effect I kind of saved on the side in our snippets file because, like I said, it's really cool to pixelate the screen and create a grid. And like I said, there's other functions I find. Like some of these weren't perfect. Like this is like the best option to map depth information, but I want to save them just in case I need them or I'm just not using these equations correctly. So yeah, and that's just set deferred. We really looked at it using my Git tool. So yeah, we're gonna bring in, I guess, quads, face cube. We're gonna bring in our intersect highlight shader. We're gonna create a shield and a cube. When we're done with ready, it's another chainable function. So we just say, okay, set deferred rendering. We want that. That's the shader that we're going to use for the final rendering of when we're all said and done. And we're going to just put in our pre-render and our post-render functions. And we just pass in just the pointers to these functions, which are down here, which calls fungi deferred on pre-render, some predefined functions. So this way we can, like I said, keep a boilerplate, keep it simple. I originally was going to keep this completely outside of the test file, but then I realized when I'm doing post effects, I need to do extra things, especially for this one. So in this case, I am going to take the shield, and after I'm done rendering, like I said, when we're done rendering the entire scene and we're putting it as the final frame, we're going to actually start drawing on top of that final frame. So it's basically a post effect after the fact. Everything else stays the same for the most part. So we have our cube and we have our quad that we're going to use as a shield. Like I said, this is not going to be part of the scene. This is something that actually ends up rendering after the scene is done rendering. At some point, I might have to add fungi kind of like post-scene or post-objects. So this way, these things can render on post-render. So our renderer at some point needs to be updated to kind of really handle all this. Or just leave it as this for testing. I don't know. We'll see how much post-effects we need to really do to make it worth the time to update our renderer. So with all that, let's just quickly look at what we have on our highlight. We got our regular information. Our vector vertex shader is very simple. We don't need to do much. All the magic happens in the fragment shader. So we're going to pass in the depth buffer because that's the most important part. Here's our very important function, so we can kind of map the data. I got some constants in here. But these can become uniforms to make the shader better. But like I said, you should be used to. I always make things constants at the very beginning, so I don't have to deal with updating shader code and whatnot. So we're gonna have a main color for our shield, and we're gonna have a highlight color of when the shield gets intersected, and we're going to do like how deep is the intersection going to be because we want to kind of highlight it. And for now, we're just going to do some math that we're not currently using, but I need it, else we're going to get errors. And we're just going to output color. So with all said and done, this is what our scene looks like. Refresh. That's our scene. So we have our force field wall, and we have our cube that intersects it. And as you can see, it doesn't render correctly because we're not doing any depth testing whatsoever. We're kind of just drawing right on top of it. So let's see. So what's the first thing we should do? The first thing we should do is this line is probably pretty good. I just want to quickly show you what we're going to do first. So as you can see, the force field draws on top of our box. Like, it shouldn't really draw on our box. It should be drawing around it. Like, it should not be on top of it. So what we need to do is to test where this pixel that this being drawn to compares to, like, let's say the pixel on this wall. Because if the pixel on this face of the cube, not wall, is closer to the camera than the pixel here, because you got to think about it, we're drawing everything's being converted into flat 2D world. So it's just two pixels that are fighting for dominance, and right now the green is winning out. But the green has a depth that's further away from the eye. So the pixel that's closer to the eye should be the one that should win out. It should be red. It shouldn't be this red mixed with this kind of transparent green. So with that idea in mind, like in a previous lesson, we use our fragment coordinates to grab the pixel in our depth shader that we want. So we pass that information into textual fetch, and we point it to our depth buffer, and we get our z depth buffer information. Like I said, we have to get x, else any other value I think should be 0, or they be the exact same thing. Like I said, you can use x or you can use r. It does not really matter because they both equal to the same thing. So our texture buffer, this, like I said, in the instance of our cube, everything that's on the screen is our texture buffer, essentially. It's our texture, or it's our color buffer and our depth buffer. This green part is what we're drawing on top of everything. So when we're drawing, we're going to say, okay, this pixel on the texture, does it equal this new square? So GL frag chord Z is the Z position of our new square. Z text depth is the Z position of what's currently in our color texture and our depth texture, basically. So if the pixel of our shield is greater than let's say the distance of the eye for our shield pixel that we're currently drawing in that fragment is further away than this one we want to discard. That means we just exit out the loop, completely exit out. So if we click save, you will then see that we actually stop rendering on top of our cube. And there you go. Now we're already starting to gain some intersection. As you can see, now we're kind of starting to simulate that intersection effect. Now we're no longer drawing on top of our cube. It's perfectly where it needs to be. So we're starting to do some manual depth testing. The system is not doing it for us. We're doing it now. We're actually programming the depth testing. So we got a little bit of depth testing done right now. So like I said, this pixel, let's say if we get really zoomed in, that pixel that's dark blue is slightly is further away than the green, so that's why they get merged. But when on this side, this pixel is closer to your eye, closer to the camera, so it gets rendered as is without being drawn to. Actually, this has already been rendered, so I'm not drawing. Since we're discarding the pixel, we're just not drawing the pixel at all. So we're drawing, but when we get to this depth, we're no longer drawing. We're just saying stop, just cancel drawing altogether. So now we got some more code to look at. So now we need to, since our texture map, our depth information is between 0 and 1, that's what we're using here. I have an example here. It's the same code, but this one's doing a lot of math to convert it into something like a more usable value that we can actually test in the long term. So here we're going to convert our pixel depth to like basically world coordinates. Basically, that's what we're kind of doing. We're going to take this 0 to 1 value and we're going to bring it into world space coordinates. So this way we can use this as a world space z position. So it makes it a lot easier for us math-wise to kind of just deal with it. And we're going to do the same thing to the current fragment we're drawing for the shield. So we take those two. Then we get the delta between the two, and we get the absolute. So our texture minus our current fragment, it gives us our delta. What is the difference between these two? So if our depth, let's say, is 4, let's say, if it's 4 and this one's 3, our new pixel, so the difference is 1. There's like 1 unit of space between the two. And like I say, this is world space, right? So this is the exact same thing as this one. So when I was doing it this way, it's like, you know what, I'm doing too much math. I can actually just start discarding it way before then. So that's why I kind of commented out and have it mentioned that, for optimization reasons, let's just use the original 0 to 1 value and compare that and discard. So this way it saves us from doing all this math. So that's why this is here. I just wanted to give you, there's more ways than doing it. And sometimes you should really go back at your math and start to take it apart and say, hey, maybe I can optimize it if I just don't do too much math. So that's that. So now that we know the delta, the difference between the two. So let's say if one is 3 and the other one's 3.1, the difference is going to be 0.1. So we're going to test the depth. So now we're going to have a nice if statement right here. So now we're going to test if the z delta is less than the highlight. I can probably say actually equal to as well. That probably makes more sense. Less than or equal to the highlight value. In case that messes up, I don't want to mess it up. It shouldn't mess up, but I don't want to mess anything up right now. So if the delta is less than the highlight length, so the highlight length is 0.2. So we're looking for a length of 0.2 or less. We can use any size we want, but for now we're going to use 2, and we'll play with that value later. So we basically want to know how much of an intersection we're looking for. Because we want to highlight that entire intersection. So if that intersection, that difference between the pixels exists, we're going to color it red. If not, we're going to color the shield. Refresh. And there you go. And that's, like I said, we're testing the buffers and the distance, and that's how much distance is between every pixel that's colored red. The distance between the depth of our current fragment and basically our previous fragment is within that 0.2 range. And there's really actually not too much when it comes to, once you have everything set up code-wise, it's not a lot to do. As long as once you have everything mapped, you got the difference, and then you can use world space values to kind of very easily define how wide you want things. But this looks ugly, so we want this to really look like a shield. We want it to be kind of like this. So we comment out the red. Oops, took out too many. So we got that. We're gonna use our highlight color, which I have set as green at maximum. So we're just gonna get the RGB. I really shouldn't even make it a vec4, but like I said, I was prototyping. I forgot to clean up certain things. So we're gonna use the green color as our main highlight. So we're gonna instead of highlighting the red, we're gonna highlight it green, and then we're going to make it an alpha blend. So the further away from the main intersection, the shield color should fade away. So we're going to get the z delta and divide it by highlight length. Since z delta is going to be less than or equal to, like I said, it shouldn't cause much of an issue. Less than or equal to highlight length. This would basically normalize the z delta value. So this will convert it into, let's say, a value between 0 and 1. Now we're going to say subtract 1. So we're going to invert it. Because I think if we don't invert it, we get, why not? Let's really, because I feel like, because I've done a lot of this optimization, or like, I guess I want you guys to see the progress of how I went to go about this, instead of just, hey, this is why we did it. Let's see what the visual mistakes are that I came to the conclusion I have to do this and that. So let's say, okay, I have RGB, and I want to just make the alpha blend. I just want to blend it with an alpha. So the further away from the main point of intersection, I want it to fade away instead of being a solid color. Like right now it's a solid color, I want it to fade away. So if I click refresh, now as you can see, the further away it becomes brighter, and when it's closer to the intersection point, that's when it fades away, and that's just the bad visual. So that's why I was like, well, since it's backwards, I just say 0.1 minus, right? So this way I just invert the value. So when I invert the value, now it's correct. But now there's another visual mistake happening. So this is fading all the way down to 0. But that really shouldn't be the case. Because the reason I'm saying that is because the shield itself has an alpha value. Right? The shield itself has an alpha value. So here's our main color has an alpha value of 0.2. So it's being drawn at 0.2. So the issue is that when I'm drawing, I'm going past 0.2 down to 0. And that's where you get this weird artifacts of drawing. So that's a problem. It's like that ruins the illusion. So with that in mind, so I don't want to go back to 0. I don't want to render that fade all the way back to 0. So the maximum color. What are colors I'm looking for, or what is the alpha I'm looking for? I want 1. So I want when it's close to the point of intersection, it has to be 1, and the lowest value should be the color of my shield. So since main A is the color of my shield, I say give me the maximum value. So this bit of code will give me a value that goes from 1 to 0. But I'm saying I want the maximum, and A2 is 0.2. So once this goes under 0.2, it's no longer the maximum value. So I end up cropping it or clamping this to. I probably could have used the clamp function too. Yeah, I could have. But this is better because I have to put this value in, then I have to clamp it between 1 and this value. This way is better because I guess it's an easier function. Like it's a smaller function call. So yeah, this is better than using a clamp. But I am basically clamping. I'm basically clamping this between whatever the maximum this is, with making sure it does not go smaller than that. So I'm clamping it. So if this becomes 0.1, so you have 0.1 and 0.2, this is the maximum value. So it'll always be 0.2. So when I click save and go back to here and refresh, that little artifact will disappear. And there it goes. It's probably still there. It's barely noticeable, but you have to be like really zoomed in. Yeah, you have to be really zoomed in to see it. But when you're like kind of zoomed out, you can't really tell that very well. And there you go. You have a nice intersection, and it's generated at real time. And to have fun with the shield, we're going to just finish it up. We're going to animate the cube. So we're going to move it back and forth. in our scene. So we're going to click refresh. And there you go. It just renders this. It goes like, it's kind of like the old Star Trek series when you kind of go through the shield, and it kind of like has that weird popping effect. Like when it comes in, I think Star Trek did something like that too. It would just kind of just pop right in. It's a really cool effect, and it pops back out. So there you go. So this is the basics of basically building this kind of force field. Because that's where it's intersecting, and it's intersecting that. So all you have to do is a bunch of depth testing, really. I don't know why it's intersecting there, because that's in the middle of the sphere, but that's not my code. But yeah, there you go. Now we're like I said, this is the beginnings of that force field. So now we have, but we basically built that wall force field that I had before. Yeah, this one. So, if you want to play with the shader, you can always, add that little effect to it. And then you got those lines in the middle, that's textures. Once I do the sphere, I'm gonna do texture. So you can always apply it to the wall shield if you really want to. But yeah, like I said, it's pretty neat. It works really well. Like I said, you can play with the length if you want. Let's go to highlight. Let's make it 8, I guess. I'm gonna make it 4 times bigger. So if we click refresh, you can see that the point intersection is going to be a lot bigger, or like what we highlight. The only so there you go. So like whatever effect you're kind of looking for. A wider one might actually look pretty good. That looks kind of like it has a better fade effect. And it looks like it really trying to pop out a little bit. So yeah, there you go. This is cool. I like this. It'd be kind of cool if I can maybe add distortion to the box, to the square. But I'm going to do that to the sphere, to add distortion. So this way the back behind this field, behind the shield, it looks like it's distorting the visual aspect of it. That might be kind of fun to figure out, learn how to do. I believe this guy, if you go to his YouTube video, he animates. I want to he actually does supply source code for it, but it's all in Unity code. So you kind of have to translate that into GLCL. Like certain functions don't exist. Like there's a function that does this, and that's where some of this stuff came from. Because the one inside Unity is called linear eye depth, but like I said, this doesn't work correctly for me. I found another one. This didn't work correctly for me, but this one worked. So it's the replica. So if you're going to go through Unity and you see functions that it's built into the language, you're gonna have to Google around to find some kind of equivalent somewhere that someone wrote in C++ or C# or because like I said, and you might find multiple versions of it, and you just have to try them all out and hope for the best. But yeah, that's the only issue with using Unity as a basis. And like I said, all that depth stuff is built into the language. Like I said, it took us 2 videos to just set up the depth buffer and deferred rendering. We have to actually write all this manually. So that's kind of like the beauty of Unity. Everything's kind of done for you. All you have to just go in there and start writing your shaders, and you're done. It's no big deal. All that deferred rendering, all the texture mapping, all that stuff is done for you. But as you can see, we got this done in WebGL. It took a little bit of elbow grease, took a little bit of work, but we got it. We're gonna get there. It's just a little harder, but you get to learn how it's done. Like how it really is done. You don't just see the shader; you actually see the actual framework of how this is put together. You know how to make a frame buffer. You know how to do deferred rendering, where you're going to render everything, and then you have to do this as a post effect, because that's what it is. It's a post effect. And you may have to do several layers of post effects. That's what post effects are. You kind of just you just keep adding effects on top of each other. So yes, the next video I'm going to try to do the sphere. Hopefully that works out. I'm going to do a sphere, see if I can do some kind of like the halo effect. Like every field has a halo effect. Got that halo effect. Maybe do some textures. See if I can apply textures. I'm assuming the further away. I'm just curious how to fade that away. I'm assuming maybe from the center, the distance away. I don't know. The pixel, like from the center. The further away you are from the center, maybe the more you fade away. It doesn't work because that's also from the distance. It might be a depth thing. So, like I said, this part I'm curious how to fade that. It might be an actual depth thing. The further from center. So yeah, I'll go through it. I think there might be samples in him there, in his shader code. I have to kind of just figure out, translate it, and see how can I apply this in WebGL. But yeah, if you're really interested in this stuff, tell me. Like this is some really cool stuff. I actually Googled around, and there is no WebGL version of Shields. There's no example of it. So that's kind of why I wanted to do it, because it hasn't really been done. Maybe I just can't find it, or maybe I'm using the wrong naming convention for it. But yeah. So yeah, there's some. Is this a YouTube? Yeah, it's Unity. I like how it kind of pixelated. But yeah, you always find this in Unity. Very easy in Unity. But like I said, now we have it in WebGL. We're gonna like I said, we're gonna build that. I'm gonna do my best to build that force field in WebGL. So yeah, like and subscribe. I have a Twitter. I keep adding new things. Maybe I should, at the very end, I should do a Twitter thing in case you guys want to look. Like this one I think I found last night. This is really awesome. I want to work on this in the future. Hex grids. All the math of how to build hex grids, and how to access them and everything else. How to make circles. Like this is really awesome. Like this, because this way you can do some really cool like board games. And I've seen some other cool effects with it too. So it's a long, very long article that literally gives you every bit of information about hex grids that you can get. Like this is awesome. Like it's basically like a Pathfinder. That's awesome. Like it's a freaking Pathfinder through a grid. This would be great for games. Like if you're gonna make this into a board game and you want to move a character, you can actually then this gives you like all the math and instruction on how to do it. This is like one of the most awesome articles I've found so far about hex grids. I did something a year or two ago about Unity, about making a hex grid, and I didn't have this article, so I had to do it, and I did it in a really bad way. But there's apparently very good mathematical. Like this is awesome. You can actually go around. That's pretty neat. It's like at some point I might have to go through this entire documentation and just really just do this in WebGL. Like maybe focus a game around this. But I want to do other things first. But this is like definitely one of my big things. But this is something I might have to do after terrains and what is the other thing I want to do? It's some voxels. I want to do voxels and terrains, and then maybe once all said and done, I'll do this. Unless there's a big demand for doing hex grids, then maybe I'll do this a little bit on the side. Every once in a while, I'll do a little here and there to just how to build it and how to do it. Like I said, it's a lot of math. Some of it might not make sense at all. But like I said, this is like whatever. I'm spending way too much time talking about this because I really love this. This is awesome. But yeah, so if you're really interested, sign up to my Twitter because like I said, I find tons of stuff. I'm constantly researching to build fungi, and I like I said, because of one guy suggested to to have a Twitter account. Now that's why I'm using it for. I'm just giving you guys a bunch of cool information. Well, yeah, this is a cool one. Let me see. It's kind of like how to take, like, I guess I haven't really read through this all. I want to kind of do it at some point when I want to do planets and terrains. Because when I do terrains, I actually want to do like planets and level of detail. So that's when I said terrains. This is the stuff I kind of want to do. And this might be important to that because then it helps. This looks like it shows you how to bend things around a planet. How to stretch something that's straight and make it curved around a planet. This is a really great article. Has math and terminology and graphs and code samples. I don't know if this is C++ or this is pseudocode. Okay, so I don't know. So like I said, I didn't go through it too much, but yeah, like I said, if you want tons of things that I find interesting, I guess sign up for Twitter. Like I said, I post a bunch of amazing things that I find online, and these are the things I kind of want to do in the future. So you kind of get an idea of what the future holds when it comes to the fungi and game engine and whatnot, and this fun with WebGL 2.0 series. I probably spent too much time talking. Oh yeah, I don't know. I don't remember what time I started, but yes, please like and subscribe. Every Patreon, I need to do something for Patreon people. I don't know what to do. I don't know if I should just the people who donated. Do you guys want me to just kind of name yourselves in the videos? Because I've seen that before. Like people just have things fade in and out, or like have their names appear somewhere to kind of say thank you. Do you guys really care for that? Because like I said, anyone who gives me cash through Patreon or any other means definitely deserves a big thank you. So yeah, I don't know. And if you guys have any ideas to do with other things I can do with Patreon, because I'm kind of just not sure what to use it for other than to collect money or donations, I guess, or tips for all the work I'm doing. So yeah, I'm trying. Any cool rewards? Just tell me if there's any cool rewards or that might be fun for me to do for you guys. Just tell me, or like, how do you want me to thank you guys, other than trying to give you some resources that I generated, like those emote things and the Blendy. We gotta get back to Bendy, I should say, Bendy. We gotta get that soon. When I'm done with the shield, I'm gonna go back to Bendy and start animating him. I'm kind of waiting for the Blender GLTF exporter to be fixed. There's some issues with it that I'm kind of hoping. I put some bug reports on the GitHub. I'm kind of hoping it gets fixed at some point so I can do certain things with Bendy. That's kind of, it's not really holding me up, but it causes issues. Like I need to export multiple actions. It can't do that. I need to do custom normals. It doesn't do that. So yeah, I got those issues to deal with. So that's why I'm kind of maybe doing other things, and hopefully things will fix with the exporter, so I can go back to doing armatures, because I really want to do armatures. That's kind of the main thing I want to do. I want to do some animations, some animation blending, maybe retargeting, and I want to do a character control. I'm going to be able to make Bendy walk and run and jump, and have a character controller and have an Xbox all on a web page, all with WebGL and JavaScript. That's where I want to go, but the Blender stuff is kind of holding me back a little bit. So that's why I'm exploring other little things. So maybe if anything, maybe I'll just work on an animator until that. So I'll work on an animator to get one animation working, and then if Blender still hasn't been fixed, I'll start jumping into voxels. Yeah, voxels. So that's going to be fun, because once I have voxels working, I can start making a mini game I want to do. So I need voxels. So we can start making terrains with voxels too. So we can start building worlds. So we're not stuck on a grid anymore. So we can have a bendy walk and jump on these voxel terrains, kind of like in Minecraft. That might be fun. Another cool thing, it may be using these hex grids for voxels. So this way, instead of cubes, you actually have hexes. So that might be actually an interesting idea to explore. Once voxels, if I once have enough experience with voxels, maybe I can, instead of using cubes, I can use hexagons. So that might be like an hexagon world. You know, who wants to live in a square world? I want more sides than that. So so yeah, the Christmas is coming up. Hanukkah, I think, is this week. So happy holidays, really. Like, to me, I'm a winter solstice type of person, so really I don't care. So it's, in the end of the day, everything happens in the same month. It's all the same thing, right? So Merry Christmas, Happy Hanukkah, Happy Winter Solstice. So it's happening soon. So yeah, I'm hoping I will make some more videos before then. But if I get too busy because of the holidays, I just want to get that out there for you guys. So again, thank you for watching. Thank you to the Patreons. Like and subscribe. Ask your friends if you want to give me a Christmas gift. Ramp up my subscriptions, because like I said, I want that plaque from Google, from YouTube. I just want that plaque. I don't know why I want that plaque. I just need 100,000 subscribers and I get that little plaque. I want to put it on the wall. And the last thing is, I'm thinking about maybe if you like a special vlog video, like with FAQs. If you guys are interested in something like that, tell me. That might be fun, something to do on the side. Just one video, just one big question, anything you want to ask me, philosophy, answers to questions, I don't know, relationship issues, I don't know, just whatever you want to ask me. Basically, ask for whatever you want type of thing. So I guess I'll see you guys until the next lesson. Sorry for rambling on. I really probably shouldn't do this at the end of the videos. You tell me. If you guys don't like this rambling crap I do at the end of the videos, tell me and I'll try to stop. All right? So see you guys at the next lesson. Goodbye.